So what we're starting to do over the next, I would say, 3 weeks, I guess, um, is going to be on Thursday. It's going to be a lot of fun. We're going to be doing deployment. So we're actually going to be taking a break from
Mhm.
coding, so to speak, and going to be doing configuring.
Okay.
So we're still going to be coding, but it's going to be like YAML files and stuff. It'll be templates. Um, and so a lot of engineers love that stuff, particularly systems
Mhm.
engineers, because it is very systems oriented, because it's more about
Okay.
configuring than it is creating.
Okay.
And so if you're kind of if you enjoy like putting system integration and stuff together, DevOps is a very rewarding thing.
Mhm.
I tend to like it in short spurts. I couldn't do it for a long time, but because it gets too frustrated because there's a lot of details that go into it. But
Mhm.
a lot of engineers turn into DevOps engineers because it's got all the different things working together and all that kind of stuff.
Yeah.
It's pretty cool. So that's what we'll do. We'll do a couple different versions of it on Thursday. And
Mhm.
that's when you'll be able to go to the web. It'll be public. You'll be able to connect the apps and stuff to it, and from all over the world, it'll be sweet. We'll do DNS. We'll configure the DNS. We'll do SSL certificates, the whole 9 yards. So it'll be really cool. Oh, and then we'll do CI/CD, continuous integration, continuous deployment. So every time you push to your master branch, it will automatically deploy
Okay.
um, publicly. It's cool stuff. You guys will like it. Whether or not like you could do it immediately, you'll respect and enjoy the flow of it. And then the next week, we're going to be basically we're going to split it up. I think into two parts. I'm going to do the first part doing more advanced deployment, and that's going to be
Okay.
more presentation style because it's just so much stuff. Like, there's no way we could configure Kubernetes in 4 hours or any of that kind of stuff. It's just
Okay.
too complicated. But I want you guys to be exposed to it because this is the stuff that we use
Okay.
in in like enterprise and stuff. So we'll go over like the technologies, more like word games and buzzwords and stuff like that. But stuff that once you do what we do Thursday, you'll have an idea of how the rest of that stuff. It's more tools on top of that, stuff like that.
Okay.
Um, and then Justin's going to finish the next week with introduction to native app development and the differences between web development and native. So if you want to do like an Android or iOS app,
Mhm.
you might say, well, that's getting a little bit too far from what I want to do. Actually, that's probably more common, honestly, because
Mhm.
if you're going to do automotive autonomous systems, you're probably going to be developing on like, iOS or more importantly, Android. And so we'll introduce some of those concepts. You'll see how similar but dissimilar it is to web development. We're going to use React Native
Okay.
and stuff like that, and give you some tools to make that a little bit less frustrating um, than most people find. Most of the traditional developers, I mean, it's just so much crap that you got to go through. So we've kind of streamlined it in a sense and used some of the newer tools like Expo to help, uh, you know, um, alleviate that pain. The next week we're going to be doing microservices, and so
Mhm.
it's taking all the stuff that we've done up until this point and then
Mhm.
deploying out a little bit more. So we're starting to now integrate APIs. We'll do some optimization in the cloud, maybe some machine learning, stuff like that, and kind of tying it all together using fast API. Sumo in the cloud, so we'll actually be able to run optimization and do predictions
Okay.
using model-based control, stuff like that. So stuff that we as engineers do daily, but actually now tying all of our systems together, and that's going to leapfrog us into basically some of the other certificates that you guys can choose to take, like autonomy, control optimization, or um, other things. But more specific, electrified powertrain, stuff like that. If you're interested in going into those areas, and then the last week, week 12, is going to be basically a summary of everything, and talking through stuff, answering questions, and then talking to you guys about what's next, basically, and spending some time really kind of debriefing, and also going back, and then that's not actually where it ends because Justin and I, while our formal lecture stuff ends. As you guys have realized and know, you're not really done yet. You still have to keep reviewing, right? And going
We are
back.
doing it already. Even last week three, we were doing week three,
Oh yeah.
and I have a question on that. So on the week three, so I saw a news recently that NPM issue creates some of the not all of one package in NPM injects malicious JavaScript into one of the playing portal or something like that, right? So it was on the news. Then I thought on week three, we've installed something called course like. CORS,
Oh,
cross
sure.
origin,
Yeah,
right? So,
cross-origin resource scripting. Yeah, sure.
so basically, that is disabling. The security feature on the browser, right?
It's not disabling.
Okay.
It's configuring differently.
Okay.
And so basically, that's the cores is a default kind of. Um, so cores was designed in a time, and it still is the case in some respects,
Hmm.
in a time when backends and front ends were tightly coupled,
Hmm.
right? Meaning the back ends that you're using were still deploying the front ends, which we can still do. We choose not to because from a systems perspective, you sometimes want to deploy differently. It gives you a lot more flexibility in deployment, and we'll see that really rear its head on Thursday. I think the real thing comes into play in that we disable that because we might have multiple front ends trying
Hmm.
to from different domains and everything trying to hit our back end, and then we control some of the security in a more effective way like that.
MQTT, right?
Yeah, with that said, the browser still provides a nice level of security, right? Because they still do. I mean, you still have to explicitly say, look, this domain, like if I try to go outside this domain, I have to actually mark that as being allowed. And then when you go to actually production, you're going to tighten those things down too, so that malicious code can't be running your front ends and stuff, which is pretty rare too. I mean, that's a pretty rare thing. It's got to be pretty poorly designed. It's kind of the same thing that we were, in fact, I was talking today with one of our engineers. Who was I talking with? Oh, I was talking to Clayton. And we were talking about some of the issues with some of the hardware. And one of the that you see out specifically, like there's these chipsets that are really popular with IoT developers, but there's a huge hole in it, and it's basically this hole is the ability for if you have physical access to get into its boot sector and be able to basically discover and decrypt encrypted credentials that are supposedly in this chip. And we say, well, all right, that every single device with this chip, which is millions, if not hundreds of millions of devices out in the field now, have this vulnerability, and they can't fix it because it's a hardware thing. And we were talking through that, like, what are the implications of that? Should you design new stuff with this chip? And really, what it comes down to is the reason that it's such a huge deal is not because necessarily that the chip itself is vulnerable. That is a problem, but it's actually how people implemented the clouds and their cloud IoT interfaces that are the big problem. And what I mean by that is most of the inexperienced or cheap or lazy cloud developers, because a lot of these IoT engineers are just hardware engineers that kind of know something about the cloud but are dangerous, right? And what they've done is they've put the same credentials, the same certificates, the same secrets and stuff in every single one of their devices because it's a lot easier to provision. It's a lot easier to switch them out, right? I mean, it's just easier altogether. And when you're designing it, you're kind of like, yeah, I mean, what are the chances of this thing being exploited? Like zero. Well, now imagine that something like this big thing came out that says, well, every single one of your devices could be millions in the field can be able to be exploited. All of a sudden, you're screwed because you can't shut those credentials down anymore. So anyone can get on the cloud and or get on any of these devices and pretend like they can be on a device because they can decrypt your secrets, right? In any device, they get their hands on one device they buy off of Amazon, and you're screwed, kind of thing. And so, really, what it comes down to is that full stack knowledge to know that yeah, this hardware platform might at some point be compromised, but as long as I do a good job of being able to effectively decide and section off my security, on the embedded side to only allow that. So what I'm saying is that if someone were to get those credentials, it's only for that device. And if I can detect that, then I can shut those off. And then at that point, it doesn't matter. They have to physically get into every other device. The reason I bring this example up is because it's kind of the same thing with the client browser, right? As long as you've designed your security well at your cloud side, which is why we're so focusing on that in a full stack systems, is that interface between the client, the embedded, and the cloud side, and all the security above it of the cloud. Why we're focusing on it so much is because you can mitigate a lot of those security risks, right? And so when you say, yeah, cores is kind of disabling security on the browser, I mean, kind of if you've not done your back end right. But if you've done your back end right, the worst thing that can happen is those credentials with that system could be um, could be compromised. And at that point, as long as you've designed your authorization and your authentication correctly, it's only that account that is going to be affected. Now, if it's a super admin account, yeah, so be careful about your admin panels and stuff like that, right? Just have additional things like two-factor authentication and those types of things. But if it's just a user account, like the worst thing is that someone can access that user's information, right? Which could be bad if you're a bank, but in the end, it's still one thing. It's not like you're attacking everything. So that's kind of the approach that we take is, yeah, every time you may be trading convenience for security, which is always the age-old kind of teeter-totter thing that you do, right? Convenience for security. But these decisions are made in a very deliberate way, knowing that as long as we do what we should be doing on the cloud side, we've limited our attack surface and the impact that those decisions can make. So cores is one of those things that we've kind of said, all right, well, yeah, if we wanted to be really strict, we should probably still take advantage of cores. But what are the chances of it happening? Pretty low. And if it does, is it that big of a deal? Well, it's really only affecting, that one specific account. From that, if they were able to get that token or whatever. From the cost resource origin sharing kind of thing. And could they do it from another origin? I mean, maybe, but we're going to be doing it from other origins too because we may have native apps and stuff out there, and so we'll just limit it and be able to rate limit on our load balancers and stuff like that. We can also use machine learning to be able to effectively watch all the traffic coming in. And once we can actually, make sure that that traffic coming in is normal, we can immediately determine if something's not normal and flag it. Just using very simple machine learning techniques is a big thing in security right now. Is looking at logs and just training your models to say, okay, this user tends to operate in this way. If something happens out of those bounds, then it flags it. Maybe, and if you're really concerned about it, maybe a severity factor associated with it, it'll shut it down. Stuff like that, and then make the user, maybe log in again or do something to prove that they're actually that user, stuff like that. So there are other things that we use on a daily basis that kind of help with mitigating those types of things. Right. Any other questions? Cool. So JC, I know you wanted to do some stuff today.
I think I muted. I have one last question adding to that. So we were talking about integration testing. JC was talking about integration testing when the week 3 when Bethan was asking a question related to that. So all this security related checks will be done as a part of integration testing, or
yeah, we always write integration, or you should. Maybe so we don't always, but you should write tests to verify your authorization. So you basically, like, up until this point, we basically have a template that we use because our authorization authentication is relatively standard now. What we do is we just make sure that you can't hit a resource that you're not supposed to be able to, and you just kind of go through it and do some verification on those types of things. There's also a whole area of security called penetration testing. And what that does is whole security teams will come in and then they'll just try to attack the system specifically in those areas, right? They'll read the whatever documentation is available, like the API docs and things, and then they'll try to exploit certain areas that they think they may be able to do, like, attack a UID or see if they can cycle through some UIDs and find one that maybe is not gated appropriately, stuff like that. So that's one of the things you'll do in integration testing. Yes, is make sure that those walls hold up.
Yeah, and you'll set up tests where you'll have things that you'll say, this should fail, right? Like I'm going to request to get X resource and I should fail to get the resource. And actually verify it's funny because you're passing a test by failing something, right? But you set up the criteria for the test such that you intentionally fail.
I mean, we know that automotive, right? I mean, more of your tests are about failure than they are about
Yeah,
success, right?
yeah, yeah.
Well, that's actually like a funny Six Sigma concept, right? It's where they work with trying to characterize a system, and one of the big things about durability testing is you get so much more data or
Mhm.
so much more valuable data when you test something to failure versus seeing if it passed, say, 100, 200 hours of some durability test, for example, and it's a binary did or did not.
So we do that in going to the static testing. We try to test the load envelope. We try to break the wing, and we try to break the fuselage sometime
Right.
to just see the the load envelope. Yeah.
Hmm. Yeah, exactly. Well, in the loading, in yours, which is breaking a physical thing, we do load testing too, where we just pelt the thing with as many connections as possible to see when it breaks and if we
Okay.
scale appropriately. And we'll talk about that next week in deployment, or Thursday, and in deployment, and how that kind of comes into play.
Thanks.
So if you guys, is everybody ready for a little bit more front end? It'll be like today, I promise.
Basically, just doing things we've already learned. It's just a little bit more stuff that you guys can watch and take in.
We'll
No
just
new content.
pretty it up, and we'll take advantage of the vehicle context that we set up at the end of Thursday.
So no new content. JC, you got to promise. No new real content. Just
Nope,
rehashing what we got. All right.
exactly. It's more of what you already know. All right, I'll get started here. Let me grab the ball. All right, you guys see my screen?
Yes, JC.
Yep.
So everybody's familiar with this login. It's what? Lorem ipsum 123. All right. One thing I'm going to do real quick here, I'm going to actually add a little bit of margin so that I center this. So this is the index.css file. What I'll do is I'll set this to 3 rem. This is for top bottom, and then for left right we'll say auto. All right, and then I'll just set the max width here to just 1,000 pixels. So that does just a little bit of centering for us there, right? You see that when I get it out here? All right, and then let me see, for that app itself, I'm gonna set that a margin to 50. Give us a little more. And this should set it up so that even when you squeeze the screen down, you see how it's keeping that margin between the exterior of the screen and whatnot. That just gives us a little bit of space so you don't run your words all the way up to the edge. Just like a margin on any kind of like 8.5 by 11 piece of paper, right? Now, really what we want to work on here is this home screen. So you know how we styled this about screen, gave it a card. Let's go ahead and put this home screen in a card. And on top of that, we'll actually add some really interesting data based on what we have from the vehicle context. So let's go down here into screens, and then I'm going to copy and paste this account module .css over here and rename it to home.module.css. And we can import it. Sorry.
You there, JC? Where'd it go? Well, I guess we'll wait for him to come back. Any questions in the midterm here?
Can you elaborate a little bit on the concept of windows and document when we talk about, like, there's something, we have been talking about DOM, and how does window come into play, like when you...
Yeah, so window is part of the um, so window is part of the DOM API. And the thing about window that you typically don't go for and you use is because window only works for that specific page at that specific time. So if you try to attach an, let's say, a JavaScript object to a window, it's global, right? And that's not necessarily a bad. You might say, well, then why can't we just use that, right, for our state management stuff? Well, because number one, the window is synchronous, and so it technically could be blocking. So if you have multiple components trying to use it and set it, you might have synchronization issues, race conditions, things like that. The other thing that window doesn't necessarily provide you is the ability to flexibly share content across tabs. So if you think about that, that's actually a really interesting thing, right? Because now you might say, well, how does the context also allow you to do that? Well, not really, but you can. There are certain things that you can do and certain things you can't, right? With different when we're talking about MQTT, sharing sockets, things like that. I mean, you might actually want to share sockets across. Sometimes you can, but you can't do that if you attach it to the window API in the DOM. The other thing is the window API is not necessarily uh, it's not necessarily a very effective way of managing all of your state. And the reason is because it's really tied to your specific browser, and the window API is not particularly consistent across all the browsers. I mean, most of them are pretty standard. So if you just use the standard window, it's fine. But if you want to use anything beyond that, like any special stuff, especially when you're talking about things like your audio APIs, your navigation APIs, things like that. Those are all over the place between browsers. And so you can't necessarily be guaranteed that the window API is going to be consistent across everything. And so that's why I think historically people have moved away from using window, and we just don't use it as part of the document object model.
Understand.
Yeah, sorry about that, guys. My laptop just restarted on me.
Oh, that's weird.
Yeah. Yeah, I'm just about back.
Okay. Yeah, we were talking about the window API. So it's got me thinking. I'm gonna look into this. Why people don't do it. I do know that yeah, I'm seeing it here. It's what I said at the end there was that most people still don't use it because of the fact that it's not consistent. The API is not very consistent across browsers. This is interesting too. So So it's actually kind of split here. I'll put this in the chatter. That's a very interesting question. So, here's a good discussion on Stack Overflow about it. Um, it generally looks like it's kind of split from a quick look here, but basically there's some issues with the global scope can be frozen, not writable in some cases, and I think it has to probably do with the application, um, and then um, and then yeah, and it has to do with the synchronous ability of the window state. So the first thing I said actually is that sometimes you won't be able to actually write it. Um, in multiple ways. So it's not very performant or can't be very performant. Then others are saying, well, you could, but you'd have to make your own unique namespace because who knows whoever else is going to be using that can overwrite the window, API. So if you're using other libraries, who knows if they're doing it? They shouldn't be, but if they're doing it, so yeah. So there's a couple of different ways. Although that looks like it got downvoted like crazy. So I guess the community spoke on that one. This is also an old question because it was asked in 2012 and they were using jQuery to ask it. So yeah. And then there's an interesting thing here about jQuery also, a whole GitHub issue about it. That's an interesting question, so I guess we just don't use it because we were told not to in the beginning, but I think we've answered why we don't generally use it. Technically, we actually do use it sometimes because we actually do use the event API, which is actually attached to the window. But
Yeah, that's true. Yeah.
But we only use events in the sense of a dispatcher, and so they're very generalized, and we only use basically one, and that's what like Redux and our reducers use. And under the hood now with context, that's kind of what context uses to manage that. So it's not really we don't really use it. We use it through a chain of things that controls it. So we're not kind of left to our own devices to potentially do weird stuff with it. Yeah. If you want to store data, I recommend using local storage or cookies, server-side cookies or something. If you need persistent data across sessions and even a reload, save it in. And then some browsers will support like WebSQL, stuff like that, like little data stores. I've not used those typically because you're kind of have to make sure that you're using the same browser because those APIs are all over the place,
Okay.
completely all over the place. So. Almost ready, JC?
Yep.
Did it reboot because of a update or something?
No, looks like I got battery problems.
Ah, that's not good. MacBook Pro,
Uh-uh.
2016 MacBook Pro. Sometimes mine shuts off at 50% battery. Those damn battery engineers. What were they thinking?
Yeah, mine was at like 70% when it started. Here, I'll go ahead and share my screen. All right, so once we get started up here, I'll jump ahead and actually open up the files. All right, so this guy was misspelled. Then we need to import styles. Just to recap, guys, we were updating the home screen. All right. So what we're going to do is we're going to update it so that it's got like kind of a nice card, just like our account screen there. Okay. I'll comment out this for home. Open up the home modules there, and we'll call this one home card. All right. Border style none, margin padding's good. Border radius, same thing. This is pretty much the same as our account card. All right. And then we'll also have our account card list. There's our home card list. All right. And the only other thing that I actually want to style a little bit here, since we're going to have a bunch of different items, is the LI tags that we're going to put inside of this, which is, I just want to give them a little bit of margin at the top. All right, now we got to bring these styles in. So if you remember, this is going to be class name, home card. And then instead of these P tags, I'm actually going to put these into an unordered list. All right. So let's just change this H2 just to say home. And we'll bring that user first name into another one of these list tags. Change these both to LI. Remember, LIs go inside of our unordered list, right? Each of these are a list item. And what I want here, so we're going to have one that's going to be the user, all right? And then we'll have in here, this will be first name, right? And then we'll have last name, and we'll also put email in here. I'm going to go ahead and make each of these tags at the beginning. These little section markers, I'll put a strong tag in. That just makes them bold. So what I'm going to do here is I'm going to make a list of things that we want to show, and then I'll set it up and show you guys how to do the calculations based on the vehicle context to show each one of those things, right? We're going to have and we're going to do some kind of some fun JavaScript on the way just to get those calculations, because some of them aren't that straightforward. Another one that I want, let me copy and paste this just so we can get those strong tags already. I want last report. Data here. The next one's going to be inventory size. Vehicle makes. So we're going to actually have a list of all the makes of vehicles that are in our inventory, right? So you could have 6 vehicles. If they're all Honda, then you're only going to have Honda show up here, right? So this is all unique makes. And then the next one I want are the model years. I want to show what the range of model years are. Okay. So once this reloads, so these are the pieces of data that we want to pull in. All right. The first one's pretty easy since we actually already have this user here, right? So it'll just be, remember, if you're writing inside of JSX, in order to actually insert some JavaScript, to go back into JavaScript domain, you have to put these curly braces in. So it'll be user first name, user last name, right? And then user email. So Lauren Ipsum at laurenipsum@example.com. So all right, now let's get interesting here. Let's do last report. All right, so I want vehicle data since the data is really what contains that last report information. And I'm going to make a function called get last vehicle report. And it's going to use vehicle data. I'll make a dummy variable here. Just call it latest vehicle. And set it equal to an object with timestamp at 0. You'll understand why I'm setting this up as a prime at the beginning. And then the text, this is default text. I'll just say there's no data available, right? In case the actual vehicle context doesn't have anything loaded up into it. And so what we want to do, the latest data, right, would be the timestamp that's greatest. Because the Unix timestamp is the number of seconds since 1970, right? And so if I want the most recent, I need the biggest timestamp, that biggest integer. So what we can do, we know that vehicle data is actually an object. And remember the way we stored it, each key in that object was the UID of the vehicle. So I can look at the object.keys to get a hold of the keys of vehicle data. And then I can map over this array of keys, right? Where this key here, this is the UID. And then I just say if vehicle data, key, right? If this particular one, if that timestamp is greater than what I have here is my latest vehicle at the moment, dot timestamp. And this is why I set it to 0, because I know that the timestamp's definitely going to be greater than 0, right? If that's greater than the latest vehicle that I have stored, then I'm going to restore this reference. I'll say, okay, now this one's actually going to be my latest vehicle. All right. And so this would be the latest vehicle variable is like the latest vehicle data. Okay. And now I got to make sure that it actually has a vehicle UID on it. We dictated this format in our where we set the actual data, and then the way it comes in. I can come back over here to vehicle context here. Let's see. I think it's in the private route that we set that. So we actually do our request of vehicles here, right? And then we get that latest data from the latest data route, and we set it here as latest data. So if you look at the way the data gets returned, there should be a vehicle UID that gets returned on that object. All right. So I have to make sure that I know which one it is. That way I can actually obtain it from this vehicle list. And so I'm going to say, all right, last report text. Make sure we're going to use a package called moments. I need to import that up here. If you guys remember what we did in the cards before, we had, let me comment this out so you can see the vehicle screen real quick. If you all remember what we had in the cards here, there was a, like, the last data reported 5 days ago. This is what I want, right? But what I want is the most recent out of all the vehicles, is what I'm trying to find here. So it's a summary. So we look at this last report, we're going to see when it was, and we're going to know which vehicle model actually was the one to report last. In order to do that, if you look the way this is done in the vehicle card, let's see here. Under this last report, we use this moment from now function, and that's what we're going to do here. So I'm going to say it's going to be moment, and then we want the vehicle or latest vehicle, that timestamp. It needs to be in milliseconds, so we multiply it by 1,000 and we say from now. And that gives us the text we saw there 5 days ago, 4 days ago, 1 hour ago, 2 minutes ago, etc., however long it was ago. And then Moment does a good job of formatting that for us. And then what we need to do, now that we know that we have the UID of the latest vehicle to report, we need to grab its information off this vehicle list. And so we can use, sorry, is there a question?
Yeah, so maybe I missed a big picture here. So the Redis basically give us the latest information, latest data, right? That is a cache database.
This would be the latest, yeah, so it's the latest data that is within the vehicle context, right? And so the idea is that your vehicle context should constantly be getting updated, right? And as long as that's being updated, then you can grab it straight from the context. So the idea here is that in this layer, in the presentation layer, you're trusting that context is being kept up to date, right?
I got it.
And at that point, you would want to. So one of the things, that's a good question actually. One of the things we'll want to do to truly keep everything up to date will be to move MQTT, right? So we have MQTT set up here on our vehicles. We would actually want to move it up into our private route because we know that that private route gets used on all of the pages, right? But what you're doing here is you're just trusting that what's coming out of the vehicle context is up to date. Just it kind of compartmentalizes it, so you don't have to worry too much about how that data gets updated. You just trust that it gets updated. And so what I'm writing here is just a nice helper function. It's to try to use the vehicle context data that we have, and out of that, figure out which vehicle posted most recently, and then just report that as a quick summary. And so we know we've got our latest report text, right? And we know what the vehicle UID is that last reported. Now we just need to actually grab its information. And so arrays in JavaScript have a nice function called find. So we can say vehicle is going to equal vehicle list dot find, right? And we want to pass in a function that'll return true when we find the one we're looking for. So we'll say out of the list, we know we have UIDs, and we want to make sure that UID is equal to this UID here. All right, and as long as it finds something, so we're going to say if vehicle, as long as you did actually find that vehicle UID, then we'll overwrite this text. Remember, we wrote this text up here initially, no data available. Now we can actually set this up, so it'll be vehicle dot year. We'll do vehicle dot model dot make, vehicle dot model dot name, and also the last report text. And at that point, we just return the text here. All right, and so we can actually put that right here. So instead of saying data here, I'm sorry, here at last report, we can invoke this function with our vehicle data. All right, let's see what we got now. So our last report was a 220 Chevy Bolt 5 days ago, right? We can include other information here if we wanted to be really verbose. We could put the UID, right? But this is just to show you guys how you can kind of dig through the data and get some snapshot summary info. So the next one we want is the inventory size. That's probably the easiest one, right? Because it's just the length of our vehicle list. So in this case, we have 6, right? Now the next one, this is going to be a fun one. We want to find out what are the makes. Now, if you look at the list of vehicles here, we've got copies of makes. So we've got, say, 2 Fords, 2 Hondas, and 2 Chevrolets, right? But what we want to come up with is we want to show a list. It's just going to say Ford, Honda, and Chevrolet, right? That way we just know, okay, this database here, our inventory includes these makes. What we can do is we can actually take advantage of the fact that JavaScript objects can only hold keys. So I'm going to make a function called getMakeList. And then inside of that, we'll pass a vehicle list. And then I'll make a, just an object. We'll just call it the make dictionary. All right. And then I want to map through that vehicle list. So via vehicle. And then for every vehicle in that, I actually want to set a key on this make dictionary, which is going to be the vehicle.make.name, or sorry, model.make. And then I'll set that equal to vehicle.model.make. And I'll be honest, we don't actually have to set this equal to anything. I'll just set this equal to null for now, just to allow you guys to really see what's going on here. So I'm setting up a dictionary where I go through the entire list and I create a bunch of calculated keys, and then I just set the value of those keys to null. And then what I'm going to do, I want to return a list actually, right? So what I'm going to do is I'm going to return an object.keys function of the make dictionary, and then I'll join every element in that list by a comma. Let's just see what the output is, and then I'll explain what's going on here. This is a really nice trick if you ever need to get like unique entries in some kind of an array, for example. Object.keys. So we got a Ford, a Honda, and a Chevrolet. All right, just like what we wanted. So let me explain what we did here in this get make list. Remember, we got this make dictionary. You start with an object, right? And then we go through the whole list of vehicles, and then we set the key of that object to be the make of the vehicle, right? And we just set its value to null. So essentially what we have here is we should have an object like this. So it'd be, say, Ford, null, Chevrolet, null, Honda, null, right? This is what make dictionary should essentially equal, right? And so the reason that works is because objects can only have a unique array or unique key. So if you set the key to the same key, it just overrides itself. And since you know that all the keys have to be unique, then what you can do is you can remap it to an array by getting an array of the keys, which is what we did here. And all we care about is the keys, actually. We don't care about what the values are. So that's just a little trick to essentially get your unique set out of an array. And then what's our last one here? We want the list of model years, right? So let's make one more function. Let's say get year range. Pass in the vehicle list. And I'm gonna say min year is 10,000. Max year, 0. I'm just setting something, the min year above whatever we're ever gonna find, and then the max year below anything we would ever imagine we would have. And what we can do is we can actually map through the vehicle list. And I'll just say if vehicle year, vehicle.year is greater than max year, right? And this is why I set it low. Then I'll set max year equal to that year. And then it's something very similar for min year, right? If it's less than min year, if this particular year is less than what I have saved for min year, then I'm going to set min year equal to it. And then I just want to return that range. Now this is not going to be that interesting in terms of what we get here, simply because all we have is 2020 for our vehicles. So it should just be 2020 to 2020. But you can see that this home screen would adapt to any kind of data sets that we have. So I'm going to open up, see if I can access this still. FSSE vehicle.
So what you're doing is called pagination or something different?
No, this isn't pagination. This is just doing calculations on the data. That's all I'm doing. Right? I'm grabbing the list of data. I'm just trying to calculate some aggregate things about it. So just to make this interesting, let me make this 1990. I'll make this one here 2002, right? And we'll do 2015 on another one, right?
Hey, Reeve, typically pagination refers to, comes from paging. And what paging means is, typically we can't send, records back and forth. And so between, back ends and front ends. So you might, what we could do, we call paging, where we limit to like 100, but then you can request, the front end can request the next 100. So you can get that infinite scroll sort of feel. That's what we typically call pagination.
So it doesn't look like these guys are actually loading up the years. What I can do is I can load up some different vehicles. I'll go back to this main, right? Remember, we use this client to load up some vehicles.
The right database, maybe.
And then I'll change this to 1990. Change this one here to 2002. And we'll also have a 2015 here. I just need to activate, right? Now let's save, I'll run the client to load up some more vehicles. All right, now when we refresh, we should see a couple more vehicles in here. All right, 1990, 2002, 2015, right? When we go back to the home screen, now you're going to see that it actually shows the range, 1990 to 2020. And if I would have introduced another make, this would have gone up. You can see our inventory size now is 9, right? So nothing new here. It's literally all just kind of expanding on, what we had before. But you can see how you can derive some really some interesting insights into your overall view of your data, right? Just within these pages, grabbing and doing calculations in the front end if need be. The last thing that I want to do is just style this nav bar a little bit, make it in line with the card, and then I'm going to add there's a neat website called Logo Maker that you can do to make you can use this to make free logos. And I think I searched up one called a connected car.
So,
yeah.
Sorry, again, I will have a lot of time, so I'm asking so many questions this time. So you're doing some manipulation on the front end, right? A lot of this, everything you're doing it here on the front end. So what level of manipulation you can do on the front end to avoid the latency? Because a long time ago, BJ was telling about, now we try to do everything on the server or on the back end, and and we only do minimum manipulation or the coding on the front end to make the the page or the improve the latency or something like that, right? So
I think it depends on the amount of data that you have. Like if we had, let's say we actually had a database of 1 million vehicles or inventory of 1 million vehicles, there's no way I'd want to actually do those kind of range calculations on the front end, because you'd simply have to pull the entire data. You'd have to go and page through all of your vehicles, right, before you could even determine, what's the range. Yeah. And so those are kind of things that would need to be pushed to the back end. Technically, you'd even start, right, with what we're doing now by pushing some of those calculations into the back end, right? When you're working with smaller databases, it just depends on the size of the data that you're working with, whether or not you can get away with just doing that really quickly on your front end, or if it's something that you do want to push to the back end. Typically, like complex calculations and whatnot, you like to push that kind of complexity to your data layer. So you push that onto the back end, right? I'm not sure if that answers your question 100%.
Yeah, it answers my question a little bit, but it's me, it's not you. I'm just confusing with the backend and front end manipulation right now. So you are pulling the latest data on the range of the vehicle that you want, and right, of the year. So those things can be done on the back end too, and just pull those data on the front end, right?
Yes. You just have to provide routes that would provide that data, right? So I'd have to have a route that I could say, give me the vehicle range, or perhaps when I actually return a list of vehicles, that could be some set of aggregate data that I provide, like metadata about the vehicle list itself, right? I can say, make list, range, etc. And then perhaps on the front, maybe it's just the make list is actually an array, and then on the front end, I do some formatting to put the commas in there in the way that I want to represent it textually, right? Okay. So in terms of,
it really comes down to an architectural decision. I mean, it goes back to what Justin was saying, is that oftentimes you just decide, if you get lazier, you're like, I just need to do this quick. You might do it on the front end first because there's not a lot of data. You're already in there. You kind of know how you want it presented. At that point, you start then optimizing. And then you say, all right, well, I know this is going to get to be a big database. And so I'll do a to-do here to push this to the back end. I'm going to do it now because I'll be fine for the first, 100 users or something, but I'll make sure to do this later. The other thing is, oftentimes you push to the front end because you're not quite sure yet what people will want to see in their user experience. So there's going to be some testing, some voice of customer testing and stuff like that. At which point it's a lot quicker and easier to change in the front end, those simple calculations. And then once you solidify that, that's when you then push it to the back end and do a more efficient method of doing that. Because you can take the speed hit initially, but then once you figure it out, there's no reason to necessarily do that and depend on every client's processing power to be able to do those types of calculations. The other thing is, doing sophisticated math calculations in JavaScript is a real pain. JavaScript is not a good numerical engine. Floating point stuff is not its strong suit. So you typically want to avoid that stuff if you can, if you're doing complex stuff. With that said, I've worked with some like Cobra and others, which are like genomics modeling stuff, and like they do like whole front end sorts of implementations of these linear algebra systems that they're solving in JavaScript. I'm not sure why, but they do it. So I guess you can do it, but there's really no reason to if you have the opportunity to push to the back end. So architecturally, it's really a decision on what you do. And with that said, I mean, what JC's doing here, he's basically making things pretty and doing a presentation layer. At that point, yeah, putting a front end. That's not the back end's response, but presentation's not the back end, right? So
yeah, it all depends on whether or not it would be practical to do it in the front end at that point. It's like, if you had 1 million vehicles, it wouldn't be practical to do it in the front end because you'd have to pull so many vehicles down. But in terms of this, yeah, just quick and simple. It's something nice to show.
Okay. Yeah, sorry to interrupt. That's something that came about.
BJ, the other thing I was going to throw in there is, in terms of where you want to do the calculations, depends on as well as if you'd rather use your client's electricity.
That is a good, right. Although, if we're talking about computations versus opening a socket, you're probably spending more money opening an HTTP socket energy-wise than you are actually running a few calculations. Unless you're going crazy and doing some serious like Bitcoin mining, which is a thing on the browser. then it makes sense. But typically the user's not going to like that.
Yeah, that could be a source of malware actually. Like you go to a website and they happen to be putting some Bitcoin mining into the browser client side code, and then when you load the web page, the actual electricity that's being spent to mine those Bitcoins is running on your computer.
So they're basically mining for free, or
Right.
you're getting nothing
On
for
your
it.
dime, right? So the last thing for us to do here is just a little bit more styling. I want to bring in this icon as well. So I've already got it loaded up. I'll grab it. I decided to make it red here. This will be available in the repo so that you guys don't have to worry about actually pulling the icon down yourselves. So we'll make inside of our front end React here, and then inside of source, we'll make an assets folder. And then I'll copy and paste this here. All right, so here's our logo. Just a little red connected car. And I'm also just gonna pop that for convenience sake into our public folder. So the first thing I wanna do, this index.html, I don't know if you guys remember back to when we covered React, right? Initially going to React, all these, all React really is this index.html page with this ID div. So this div with the ID root, the whole application gets injected into that div, right? But this is really what gets loaded up. So what we want to do is instead of rendering our nice little React icon, I'll override it by putting our logo in here. So I'm going to, instead of favicon.ico right here, I'll put logo.png. Now, technically, you should resize all these things. A lot of a good size, I think, for your favicons like 512 by 512. But you can see it's already loaded that up. If you ever wonder, and also it says React app in here. We want to update that, right? So we can call this. Let's see where we're at. It should be title. There's going to be a little meta tag with the name title. Right? So here's our title tag, and this goes in the head. Remember, everything that goes between these head tags does not get seen within the browser. It's everything in the body that actually gets seen in the viewport. But this title tag is what you see in that tab. So full stack systems engineering viewer. And when that loads back up, all right. And so now we've managed to get rid of all of our upfront references to React. Next, we'll just pop our icon in here in the header and then update this nav bar a little bit. So I'm going to go into these styles for nav bar. I'll set the background color. White. All right, I actually want it the same blue as what we've got here. So let's check out what we've got for that login. And we did all these styles piece by piece, but if you're looking at actually trying to bring this out thematically, we'd create a whole nother CSS file and have one kind of central location where we would keep and contain these colors. Because you may have like a light theme or dark theme, etc. All right. And then the other thing I want to do, I'll show you guys. We'll do a little hover effect on them as well. So you can see the cursor actually turns into a nice little pointer when you come over top of these navbar links. But you also want it to kind of do a slight lightning effect. You can't see that on your phone, but if somebody's coming in here on a browser, right, you'll be able to see that light up. Just kind of helps it stand out a little bit. I'll just make this blue. Right, so you can see now, I don't know if you guys can see that on my screen, but it lightens up just a hair. All right, now let's actually go in. It's our layout that includes this header tag, right? What we want to do is we want to import our logo from that assets folder. And then I'm going to add a div, and I'll put this header tag inside of the div. That way we can include the image as well. So the source will be this image logo here. All right. The alt text is what gets shown if you can't actually load the image, right? And I think they also help with your alt text should help with people who are looking at website readers. So somebody who's blind, for example. I'll set up this inline style on this one. If you notice that the keywords are slightly different when you do an inline style, this is actually called, it's JS in CSS or CSS in JS. And the only reason it's different is because having a hash, or having a hyphen in between max and height's not legal JavaScript. So they get rid of, if you notice, they'll get rid of those hyphens and then they'll just camel case the keywords for CSS. So the max height in this case, we'll set it to 50, margin right of 20. And I want these things to be together. So its display is instead of block, because H1s are typically block, we'll set that to inline. And then for this div, which is containing both of them, add a little bit of padding left here. Display style for what's inside of it's going to be flex, and then I want to align the items center. All right, so let's see what we got. All right. So that actually takes us for as much as I wanted to catch up for tonight. Does anybody have any questions? So all we really did was added a little bit more styles to our home page, messed around with the favorite icon, right? Our title tag in the header, updated, brought in a small icon for our main header and our layout, right? Unified some of our coloring and brought in some overall calculations, right? This, let me go back to home. So we've got our user email. We can figure out which vehicle reported last, right? What our total inventory size is, how many makes we have, and then the range model years. And the cool thing is you can change your data for your inventory however you like, right? And it will adapt to it, right? So this is data driven. It's not some kind of static page. It depends on who logs in. Now, one thing that we could do is we could actually create another user in our database, and we could set this up. If you remember, we linked, when the vehicles were created, we linked each vehicle to a user, right? So we can set it up such that, and we should, such that when a user does a vehicles request, we reference that user to only return a list of vehicles that belong to that user. And so what we can do then is we could set it up so that we have a separate user account. And if we log in with that separate user account, we see those vehicles. I think, and BJ, do you recall, did we mention that on Thursday as like a small homework assignment?
Possibly. I think I mean, the homework assignments that I've kind of remember is like adding API docs, um, stuff like that. I don't
Database.
remember about adding other users, but creating a registration page is a relatively straightforward thing. Well, form validation and stuff is kind of a pain, and but from that perspective, but it's more of a detail at that point than anything. I mean, you guys can make a registration page and then look at going through the provisioning process and stuff, how you provision it with that's what it was. It was creating credentials in a different route for your data for your vehicle, so you can verify. That's what it was, JC. Being able to verify identity of the vehicle separate from the user, and then connecting them together.
Oh, allowing the vehicle to have its own credentials. That's
Right.
right, because we're using the user credentials on the embedded side.
Because we had that whole discussion about where do you embed the user. Where does the user information get stored? Does it get stored in the vehicle? No, right? That's a bad place for it to be stored. I'll get stored in the cloud, but it's more about where do you actually connect those things. Connect them in the cloud, but you connect the user information, which is really client side, to the embedded domain, and the embedded domain has totally separate credentials, and it's something that you can easily remove that link by a simple removing a record in the database, a single record in the database. And then all of that from a security perspective is completely untied then. And no one will be able to act, and you'll be able to remove that very quickly and very easily, that ability to access if you need to, or add it for that matter. So yeah, that's all those provisioning concepts and everything. And we don't, that's one of the things that we'll talk about like in the last session, kind of tying everything together, is that more conceptually high level kind of stuff. Um, to really kind of dive more into those things, because the issue with provisioning is, while we could provision this, in fact, you probably will in other certificate programs and stuff, like with autonomous vehicles and stuff like that, especially the experiential part that we're putting together. The problem is with those applications is it's so application dependent. There's no like one size fits all provisioning strategy, because that's such a complex thing, because you have user experience you have to consider, you have security you have to consider. The user experience is the big thing, because that's the initial part of where users really start interacting with your system, right? And typically we say, well, consumer provisioning is the hardest, and it is, because you got grandma trying to do her smart device. We all know how that ends, right? um, but from an installer perspective, or even a trained professional, the thing is, if you give a really nice provisioning strategy, they're going to use more of your products, right? And not to mention, their efficiency is what's important. And so the more efficient you can make it, meaning the easier you can make it, the better it is. And so user experience is beyond just consumers. It goes all the way into um, you know uh, application technicians, calibration engineers, construction workers. I know JC and I deal with smart glass, where we've got construction workers who are provisioning smart windows now, right? I mean, that's a crazy thing. These guys never would have. I mean, they use their cell phone, but for the most part, like, they're not electricians. They're not, they're not AV people. And now all of a sudden they're supposed to provision this for grandma. Like, what? So like, we struggle, with this, and we spend a lot of time thinking through it. We run lots of sessions with customers and things to really figure out what that provisioning process is. Does it come down to they have their cell phone? and they scan a QR code and it works, that's usually what we try to get down to. And if it's even better, if you can like Bluetooth join the network, it works, right? I mean, so there's so many different things you can do. I've even done things like on boats where it'll play a little sound that's inaudible to us, but that sound is coded in such a way, it's a specific pitch, that the phone can actually record it using the microphone. And if it does it in conjunction with the cloud, so you basically press a button, the device or the boat in this case plays a little sound, and then the cloud knows that the button's been pressed, and then it coordinates the different sounds with it because it knows that generally what it's looking for, so you can't thwart it or it'd be like really, I mean, it would be impossible to really, mess that up. It would actually record the sound, identify it from the sound, and then provision it. So you don't actually need any sort of connectivity or anything as long as you have a relatively well-behaved, you know, um, sound environment, audio environment. You can usually do that. We got away from it because, well, you're not always in a good sound environment, right? So you can't really be guaranteed that it's going to be able to hear that sound or where you are and everything. So there's a whole other user experience. Like that was a great thing. Like you didn't need any connectivity, you didn't need any of that kind of stuff. It just worked. It was magic to people, other than the dogs that would freak out with it, right? Because it was really high pitched. Other than that, like it was great. But unfortunately, engines are loud, waves are loud, docks are loud, and so like there was all these issues that we got into. Not to mention everyone's hardware, everyone's phone is different, microphone qualities and things. So we couldn't be guaranteed to get a pretty consistent thing. So you can see like there are so many different cool ways that we can do that, but there's all these other user experience things and environmental things and the things that make us engineers, right? That's what separates us from the scientists, right? The scientists think, the world's ideal and perfect, and it's just going to work because in theory it's supposed to. As engineers, we're like, well, yeah, it does in theory, but then the real world happens and nothing ever works in the real world. So, these are the things that we kind of, struggle with and go through. And that's why provisioning is such a really frustrating thing because it really ties every single thing we've done in this course together.
What's the problem with the QR code? That seems to be very
Okay.
common.
And that's really our primary method. It's between RFID and QR code, so or NFC. Um, the QR codes are really nice. The problem with QR codes is the industry hasn't really standardized around a QR code reader, and so depending on what you've got, like if you're making an app, that's typically what we'll do. You can integrate the camera stuff with the QR code, and so you can go do that. The issue with the QR code is that it's not always obvious that you need to scan that for users, particularly non-technical users. It's not always obvious, even if you're like, here's your camera app, look for the thing that looks like this dotted thing. For some reason, it's still over the person's head. I don't ask me how. Like it's crazy. Now this is consumer stuff, so
Speaking of QR codes, I did find there was something really interesting I ran into the other weekend. I went out to a restaurant nearby, and I don't know about your guys' neighborhoods, but they actually put a QR code on the table, and so they were using QR codes instead of handing out menus, so that people wouldn't touch the menus, right? And so you'd actually end up scanning. It was very weird though, because I was sitting there, I was like, "Where's my menu?" You know?
yeah.
And they had to come over and they explained, no, you need to scan the QR code. You open the QR code, it takes you to a page, which is like the full menu digitally.
Yeah. I mean, so QR codes are cool, but we just haven't standardized yet. Like most of our newer phone apps will just automatically read QR codes. The other thing I don't like about QR codes is the security implication of it. Because if you think about it, if you can get someone to visit a link, that's a really cool thing. I mean, we've just went through all this front end stuff, right? We can get them to download a file, we can get them to visit a link to give their location, all these different things you can do. And so, but a QR code, there is no way for even a technical person to look at a QR code and be like, oh yeah, that's going to take me to this URL. Who knows, right? You could even put facebook.com really big a text underneath the QR code and have them go to some other thing. Particularly facebook.com, we can actually do a phishing thing, a modified phish, right? And we've all heard of phishing, right, through our work probably in our IT departments. One of the more popular ones, and I've actually used this before a couple years ago, is you do a popular site, and there's a popular site in Russia, but what we do is we put the URL underneath the QR code of the trusted site, and then we put the QR code. But what we do is we point the QR code to a URL, a domain that looks like, I'll just use facebook.com as, but it was like facebok.com or faceb00k.com. Something that if you look close enough, it'd be, sometimes you don't even have to do that. You could do facebook.mydomain.com. As long as there's a Facebook in that domain somewhere, it's fine, right? Because you own domain.com, you can do a subdomain. We'll do that on Thursday. You'll see how we do that on Thursday. So you can do all these things, but what we would do is we would actually put facebook.com underneath, put the QR code. Someone would scan a QR code, we'd take them to a login page, and we would make that login page look exactly like the facebook.com login page. They would put their username or password in. We get their Facebook password, and then we just redirect them to the real one and say, oh, it's not right, enter it again. And that time it worked because it's the real Facebook page, because to them it just looked like whatever, it didn't work. And so, like, there's all these little things you can do with QR codes, and no one, even technical people, wouldn't, unless they were like really paying attention to that URL, which I always do because, well, obviously I've been through that a couple times myself on the other end. And so, like, these are things that the QR codes really are dangerous for. So, I mean, that can be a really bad problem. The problem that we have with QR codes with the glass is that we were trying to put it on the glass, we etched it in the glass, trying to get a camera phone to capture the QR code, and you want to make it as transparent as possible. That's a really difficult problem optically, even for a camera to recognize a QR code. So you can imagine, like, there's all these things that just get into, the complexities of it. With that said, QR code is one of my more favorite methods for and in fact, IoT, our managed IoT service, which we'll show you eventually here, that basically does everything we just did here as a managed service. It actually automatically generates a QR code for you for your device that you can use, and it'll have like a claim code encoded in it, so it enforces some security inside of it and all that kind of stuff. If you're looking at more secure methods, RFID is good. So you actually will put RFID, and then you have an RFID reader, and that RFID reader is connected, and then it actually carries credentials. Passive RFID will actually carry credentials. You'll notice a lot of RFID stuff coming up. They'll embed it into like clothing, fabric, and shirts and stuff, and that will carry information with it, so you can actually do identification of products, SKUs, those types of things. In retail, that's a very popular thing they do now. In fact, they will embed QR codes or RFID chips into signage, so that if you pass it and you have NFC on your phone, your field communication, you can pick it up, and then do advertising and stuff like that. That's another provisioning strategy that can be used. Bluetooth beacons are also popular. As you know, like, you always wonder, well, how did Google know that I just drove by this restaurant? Well, it knew because the restaurant had a Bluetooth beacon, and it's configured on your phone to pick those up. It has nothing to do with GPS or your location. It's actually a Bluetooth beacon. So there's other things that can be used that way too, for provisioning. It's a really cool problem. That's one of the things I really enjoy doing, just because it's a really challenging problem that really takes into account a lot of things in the IoT and everything. But it's really application dependent to do it well. Any other questions? Do you want to cover anything else, JC?
Yeah, if there's no other questions, that's pretty much all I had, unless you guys wanted me to add another user in real quick. It's pretty easy.
One last question on the week 3. I have a question on that. So in week 3, uses a fetch.then in many places. But a previous week, the BJ was explaining about await async promise, right? So is there any reason why you prefer fetch.then over async, await and async?
Can you bring up week 3? You probably did it then. I remember that because then I actually switched that out on week 6. I think I did front end, advanced front end stuff. I think will you bring that up in GitLab, JC? I think
Yeah.
it's purely stylistic. The other thing is a dot then will give you a
Promise.
yeah, I mean, async await gives you promise too. What the dot then does is give you a documentation flow in your code that may be preferred. It's really stylistic. They do the exact same thing. They literally. I always prefer async await, um, just because it's a lot less code, right? It's a lot simpler. But I can also see in some cases you would want a dot then because a dot then is like do this then that. So it's a very clear documentation and it's kind of an atomic or it's a final kind of thing, right? It's I fetch then do this, then I'm good to go because then I'm dependent on the user to click a button or something. So that's pretty common, I think. You do that week 3 live,
Three.
you see. It's right there on your screen.
I'm sorry.
Your week 3 live there, your folder. You go to your client or front end React.
Front end. Yeah.
Go to source, and then I think
Yes.
Oh, it's in.
Yeah.
Shouldn't be an index.
Not here. Yeah.
Like this here.
I think he's talking about the component did mount, and go to your screens, vehicles, right there.
Oh,
That's what you're talking about, right? In that
Yeah,
component.
that's correct.
You wrote that code, JC. Why did you do that? Why did you use dot then as opposed to async?
because it's because of actually on component did mount. If you notice the way that we rewrote the effective did mount with hooks, let me compare it to hooks for you. It has to do actually with the way React components, at least class-based components, want you to write asynchronous functions, and they don't tend to work out of the box. Like this function here is not asynchronous, and I can't override it to be asynchronous. And so what I would have to do, and what I'll show you here, is I'd have to write a sub function that is asynchronous within it, and then invoke it myself, which is like, for example,
You could put async in front of that.
in front of this.
Yeah.
Yeah, so that would be your only other option. I mean, it really is stylistic for the most part.
It's stylistic because you would put async in front of that component did mount. Sometimes I'll do that. I know why you didn't do it, JC, because you don't really want to do that, because that's breaking from a purist standpoint. What you're doing is you're overriding that component did mount function, right? And what you're doing is you're subclassing that from the component, right? And what you're doing is go up a little bit, JC. So what you're saying is, all right, class vehicles extends React.component, right? So we're extending this React.component from an object-oriented standpoint. We are inheriting all of the stuff in React.component. One of those things is a method called component did mount, and it does not return a promise, right? Now, we're override, right? That's a concept in object-oriented programming. We can override any of the functions, any of the methods and properties that are from the parent class, in this case React.component. By overriding component did mount and then changing that to an async, you're actually changing the structure of React.component, of what it truly is meant to be. So you can do it, you can override it, you have complete control over that, but you don't really want to do that, because what you're doing is you're really changing the structure of how the React developers really intended this library to be used. React library to be used. They did not want component did mount to return a promise. They specifically didn't want to, otherwise they would have done that, right? And so in some sense, if we put an async in front of that component did mount, you're totally changing the API of React. Now, as it turns out, that component did mount returns void. It doesn't return anything, so it doesn't really matter. we could put an async in front of that component did mount, and nothing would happen different. Yeah, it's kind of like whatever. But from a purist standpoint and just stylistic and also a readability and maintainability perspective, I'd recommend staying away from that, which is probably why you either wrap your own async function inside and then call it, like we did with that use effect, or in hooks, or you just do what Justin did and just do the dot then function dot then. So that to me would be the reason why you would that would be a justification as to why you don't want to do async in front of that method.
Yeah, so you can see this is an example on use effect, right? Where we defined our own on component mount and then we invoke it at the end.
Yeah.
Right?
Right. I will warn you guys, what I just said is me being a computer scientist. It's fine if you put async in front of that stuff. It works. Make it work, right? If it's clean, make it clean. But as a computer scientist, I would say don't do that because you're changing the actual output of that. You're overriding and changing the structural intention of that class and the library definition.
The only other comment I'd make on when to use a wait, like async wait, and then would be there are occasions where you would like to have something get triggered within a async function, but you don't want to await it. And maybe there are other things you do want to await. And so you can achieve that kind of behavior even within an async function by calling then. Mm-hmm. And then spinning off your own promise from that, right? That doesn't actually lock up that function there, because you don't necessarily, like, let's say you want it to send off an email, right? But you don't actually want it to wait until it's done sending off this email. You say, look, I want to trigger this email, go ahead, send it, and I'm going to keep going down the page, right? Down my function and keep continuing so that I don't hold up this function call, right? Don't slow it down on things that are unnecessary, because you only truly need to await something if you are concerned about what it's returning, right? Otherwise, you could treat it as asynchronous and put another then there. So you can even mix and match the two to optimize performance if you want to.
Yeah.
Honestly, I never, I didn't put all this thought into my question. My question, I don't understand what you said right now. I just, I deserve the recording. Later sometime when I understand completely, it makes sense. That's how I look at it. So I was looking for the pattern. And so that is the only area where you are deviating from the async await. The rest of the places you are using async await. So that was my question. That's it. But okay. The definition you gave me is totally different. I don't understand a bit of it, but later I will understand. Okay,
all right. Sorry. Yeah. I mean, what I just said is pretty foundational, and it like I warned you, it doesn't really matter. Turn the thing into an async, method if you want. I've seen it happen before, and honestly, I've done it before. So if I just needed to do something fast, but the other thing is that specific case, you're not going to see anymore because we're using hooks now. Don't use classes in React. So it's almost kind of a pedantic sort of example. The other thing, Justin, you may have just done that because you felt like it. I mean, that's another thing too. Like,
it's hard to reason about sometimes. I mean, it just depends on what you are, which one you're in the mood for, I suppose. I personally weigh more towards async await, just because it's more readable, mm-hmm. right? But being able to use then and catch directly, right? And working with promises outside the context of async await is important to be comfortable with, because you will run into a lot of code that is not written with async await.
That is actually one advantage to async the promise then, is the ability to catch errors. Whereas otherwise, if you try to do async await, you can, but you have to wrap it in a try catch, right? Which is right. A little dirtier, in my opinion, syntactically. So it's more elegant to just do a function then accept, right, or catch. except as Python, but catch,
Yeah,
right?
step by step. Okay, I
Then you
got
can
it.
do finally also. There's a finally API implementation. So like there's all of those things you can use, which is a little cleaner and more elegant, I guess. So that is one advantage, I guess. You can achieve the same thing with the try catch around an async await, but it's a little more cumbersome, I think. A little harder to read, a lot more curly braces.
Yeah, I agree, PJ. I felt same thing trying to do with try catch. It doesn't look as intuitive as like the flow what you get when you do dot then and then catch.
Yeah, it's
At least for the beginners like me. Yeah.
no, I agree. It flows a little better from a syntax
Mhm.
perspective. So
Yeah.
so that may be one reason to use it. You'll see both ways. You'll see new code being written with .then. So like you just saw Justin do it. I'll do it sometimes just because I feel like it looks nicer or feels better or whatever. Trying to show off or something. I don't know. I mean, there are a whole host of reasons why we do one or the other. But you'll notice most of it, the majority of it's async await, particularly in the back end. Particularly in the back end, it's rare you'll find a .then.
And it's funny. I mean, whatever material you try to find on internet about async await, they will start with same thing. It's a syntactic sugar, and
It is syntactic, just like JSX is
yeah.
syntactic sugar, right? I mean, there's a lot of syntactic sugar. In fact, I never heard that expression before I started developing in JavaScript. I think that expression syntactic sugar came because of JavaScript and all the flexible things you can do with it. But yeah, you can probably start seeing now why we use JavaScript so heavily. One, it's so ubiquitous back end and front end. It's not very strong from a numerical perspective, but that's what Python's for. Um, so that's really what you kind of see why we do that and why it's such a critical language. And frankly, from what I can tell, it's going to be the language of the future. There's no other language other than Python, which we're doing too, particularly from a numerical perspective. There's if you were going to say like what language will we all be coding in 30 years? Well, probably some quantum language, but if it's not quantum, right, it's probably going to be JavaScript, that or Python. There's no other language probably that you'll be seeing a lot of. Although who knows, 30 years? It's a long time. I mean, it's Python's what 30 years old, so I don't know, right? One of us could invent a language tomorrow, and it could be used in 30 years as the ubiquitous language. Who knows, right? It's all marketing.
We were using Fortran 30 years ago.
Fortran or Ada. Or
There was none of this stuff 30 years ago. It just didn't exist. So who knows what they're going to be using 30 years from now.
But I mean, 30 years ago was what, 1990? Amazingly, right? And Python
Yeah.
1989. So
it wasn't that long ago.
But yeah, so what are you doing, JC?
I wanted to just show everybody something just to illustrate a detail about how this really is syntactic sugar here. All right. So I just wrote 3 functions. One's called foo. It just returns 3, right? Here's a function where it's called foo async, right? It's an async function. It just returns 3. Now this is something important to know. The moment that you put async in front of a function, it automatically returns a promise. So these 2 functions, this foo promise and foo async, are the same, right? They look syntactically different, but they have the exact same function. That is that the moment that you put async in front of here, you're essentially wrapping what you resolve, what you return, in a promise, just like we did explicitly here with foo promise. That's why you see here, console log foo, it returns 3 directly, right? But foo async will return a promise that resolves to 3. And then foo promise will also return a promise that resolves 3. So it doesn't even matter that what I'm doing in here isn't async, right? There's no network calls. There's nothing we're waiting on. We actually are returning immediately, right? But because of the way the language is written, the moment that you put an async in front of a function, it will return a promise.
That's a good example.
Right?
But yeah, in fact, on that line, your line 4 there, in your foo promise, that's called promisify. Promisify. There's actually a built-in utility function in JavaScript called promisify. That's what it does. It just wraps the return in a promise. Exactly
All
like.
right. I can actually, if I wanted to promisify foo, I would just grab foo and resolve.
Yep. Because it'll just return a promise. It's a very powerful concept, and you'll see all languages adopting futures, or promise futures. Depends on what they call it, but in Java, they call it futures. There's a whole thing, but that was only recently introduced. C Sharp, .NET language, very popular Microsoft .NET language. They recently introduced that along with async, async functions. Python, as of 3.6, has introduced async. Oh wait, we'll see that in a couple weeks with Fast API. So, a lot of the things that JavaScript had since '95 when it was created, you'll see a lot of the older languages adopting slowly all the things that JavaScript has. So very powerful kind of thing, as you can tell here. And then there's a language called Scala, which runs on the JVM, Java Virtual Machine. Um, and it's a functional language, a lot like JavaScript, that a lot of developers. It's not. I can't say it's as popular anymore. I think it's kind of fallen off, but it really took asynchronous and especially functional programming to the next level within Java, and a lot of forget the way they said it, but Java developers, when they reach enlightenment, they code in Scala. I think that's kind of the saying. And so that's kind of where they're at. And there's some structural issues with Scala. It takes forever to compile and stuff like that. But a lot of popularity around that, or used to be. But it's falling off along with Java, as doing new systems at least. Java will never die. There's so much Java. Like COBOL, right? Will COBOL ever die? Probably not. It will always stick around. It'll just become less and less popular, and you won't be doing new stuff in it. I'm not comparing Java to COBOL, by the way. I think Java's still got a long way to go before it falls off the charts as being not popular. But yeah, probably about 5 or 6 years ago, I was doing a lot of Java programming, and I was starting to feel the pain. So I started, developing in Scala, and so never reached enlightenment in Java because I don't think that's possible, honestly. But I did see the need, and then I got really into JavaScript because I just saw everything with that and Python and all that kind of stuff. It is pretty amazing when you start. When you start coding, like when you start with MATLAB, right? A lot of us started with MATLAB. At least my generation, we started with MATLAB because that's what we did, right? MATLAB Simulink. You kind of think you're pretty powerful with MATLAB, right? And then the minute you're exposed to something like Python, like when I started exposing my students who are good MATLAB coders, and I expose them to Python, the first thing they always say to me is like, I don't think I can ever code in MATLAB again because it's so limiting. And it's true. I mean, MATLAB is a great learning language, and it gets the job done for the stuff that we generally do as engineers. But it promotes really bad habits, and it's very limiting in a traditional sense of what we've seen here in all of our stuff, right? Whether it's Python or JavaScript, it's a totally different world, and that's the case. I mean, MATLAB is very limited, and I don't think that the people at MathWorks claim that MCode or anything is some great language. It gets the job done, but it really does change your outlook when you start to see things like JavaScript and Python and things like that. To see some of these language constructs and the power that you get with functional languages, as well as async languages. What'd you do here? Oh, you're doing like scoping and stuff along with.
No, I'm just showing that these are all essentially equivalent calls except for this one here, right? So if you remember, we've got foo, which was not async, right? But we've got foo async and foo promise, which are both async functions, right? And you can see they get invoked. You can await this, right? Or you can invoke it and then call then. And you're going to get the exact same value that resolves either way, right? It's just whether or not you access it within the async function here, because you can only await within an async function. Or you access it via a callback that you pass into then.
Mhm.
And you can notice that I wrote these two functions differently, right? But they are functionally the exact same. They both return 3, and you can await it or you can call then on it, right? I'll push this up so you guys can play with this as well if you're just a little bit curious about, you know, what are equivalent syntax for these different things versus await versus then exactly.
You can paste that code snippet in Slack too for really quick. It's short enough. All right. Any other questions? All right, cool. Well, keep reviewing the lectures 2 or 3 weeks ago. Keep catching up, and Thursday's gonna be fun. We're gonna be doing DevOps, a lot of configuration, no coding. We're gonna do any coding on. Well, no coding, just configuration. So it'll be a nice break. I think you guys will get into it. For those of you who are like, I'm never gonna do this coding thing again, I think you'll get into DevOps. Probably pull a bigger salary, honestly, out front if you do DevOps. Of course, you'll probably kill yourself sooner. DevOps is very the detail is a killer. The details are the killers. But yeah, it's good. You can't replace the DevOps engine. Cool. All right, guys. Thanks.
Thanks, Jesse. Thank you, BJ.
Thanks. Good night, everyone.
Have a good one.
Thanks. Good night.
Thank you.